And hello. Hello. I would say good morning or good afternoon, but we have folks literally joining us from around the world for this, the latest in the Io-Tahoe series of online webinars. My name is Steve Friedberg, and greetings for everybody over in Sweden, Switzerland, Canada, the UK, even New Zealand. And if you're a Kiwi listening in or watching, it is very late over there, so thank you for doing so. Our guest this month is Bill Schmarzo. He is the Chief Technical Officer in charge of IoT and Analytics at Hitachi Vantara. Bill, it's good morning where you are, right?
It is good morning, Steve, where I am. Yes, thank you.
You're on the West Coast, I believe, correct?
That is correct. West Coast of the U.S., not the West Coast of Australia or any place cool like that.
Well, a lot of people would say that the West Coast of the U.S. is pretty cool as well. Bill is one of those folks, as I have said in previous webinars, who I've had the pleasure and honor of knowing for years. He goes by the moniker, it is well earned, of the Dean of Big Data. You can follow him on Twitter down there at Schmarzo, but you can see that he has a long history. He is, of course, CTO, as previously mentioned. He's also an executive fellow at the University of San Francisco's School of Management and an honorary professor at Galway. Good on you, sir. Good on you.
Yeah, that's cool.
And, which means I believe that you have the Guinness, if you so wish. Am I correct?
Oh, God. Every day I go there, every time I'm there, every day, at least one Guinness. It's wonderful.
There you go.
It's much different over there than it is here. So, amen.
Which will be for another discussion another time, I think. Bill has published a couple of books, as you can see, among them Big Data MBA. He also has a new publication out, The Art of Thinking Like a Data Scientist. And that's where we're going to go primarily in this conversation here. And it's, again, like the other ones that we've done, it's more of a conversation than a presentation per se. So, Bill, one of the things that we've heard, among other things, is data's the new oil. It fuels everything that's going on. You have a different way of looking at it. Am I correct?
Well, I love the analogy that data is a new oil, because for maybe the first time in the last 5-7 years, we've got some organization realizing that data is a unique asset to be hoarded and valued. Historically, and Steve, you and I know that this, for the last 20, 30 years, data for most organizations has been a cost to be avoided, cost to minimize. But this data is a new oil is a great phrase, because for the first time in a long time, us people who deal in data finally have people who respect us. My kids actually are like, "Wow, you got a cool job, Dad," versus, what did you do, Dad, again? And the idea here is that in the same way that oil fueled the economic growth of the 20th century, that data will be that asset that fuels the growth in the 21st century. So it's good, right? But if you really want to understand sort of the economics of data, you need to understand more about the economics of oil. First off, there's a huge difference between raw crude oil and refined racing fuel, right? There is a big difference. We don't run around the western coast of California or anywhere in the U.S. or anywhere in the world with barrels of oil strapped to the trunks of our car. No, it goes through a refinement process so it can be used by all kinds of vehicles. And in the process of doing that, the value of that oil increases dramatically. For example, if you were to increase it, use it to create racing fuel, you'd have a 17x increase in value. So there's a great analogy in that oil's not just oil, like data is just not data. You need to go through a refinement process to turn that oil or data into something of value. But there's also very different.
Yeah, I was going to say, unlike racing fuel even, data is different in a very key aspect.
Yeah, as an economic asset, there's nothing like it we've ever seen. That it defies being placed conveniently into an organization's balance sheet. And that is, what do you do with an asset that never wears out, never depletes, and can be used an infinite number of times across an unlimited number of use cases at a marginal cost equal to zero? Right? How do you handle that? How do you account for that? And that's probably the key challenge, is that people keep looking at this as from an accounting perspective. They're trying to find ways to put this on your balance sheet, but accounting determines value based on exchange, right? Value in exchange. What is that asset worth? What you pay for that asset is what goes into your balance sheet as value. But data is not an asset in exchange. The value of data comes in how you use it. It's not an accounting conversation. It's an economics conversation. And value is created in use.
And when you talk like that, it sounds almost like you're talking like a professor, which should come as a little surprise then that you've developed this model maturity index for big data.
Yeah, what we found is that when we ask companies that question at the very middle there, how effective is your organization at leveraging data and analytics to power your business models, we found that most organizations had no idea how to answer that question. They had no benchmark against which to measure themselves. They had no benchmark that told them, what does good look like in this space? So what we did was we created this 5-phase big data business model maturity index, which is really maturity model not on how effective you are with technology. It's not a measure of how good you are with SQL or Kafka or TensorFlow, right, or Hadoop. No, it's about the business model, and it exploits and takes advantage of the single most powerful concept in business, which is the concept of economics. This is not a technology conversation as much as it's an economics conversation, and how we're using data and analytics to create new sources of customer, product, and operational value. So we created this big data business model maturity index, and we use this as a vehicle for helping us, number one, understand where companies sit, but also, more importantly maybe, is how do I advance up this? How do I go from using data to tell me what happened, the classic BI space, the monitoring space where you're building reports and dashboards that tell you what happened, how do I become more predictive, more prescriptive, more preventative? How do I monetize the insights about my customers, my products, my operations buried in that data? And how do I digitally transform the organization? Not digitalize the organization, not give everybody a bunch of iPads, but how do I leverage the unique aspects of data and analytics to transform, re-engineer my business model? So we use this as a vehicle for not only assessing where people are, which, by the way, 98% of the people, I would guess, people I talk to, maybe it's skewed, right, small sample size, but most customers I talk to are still stuck in the business monitoring phase. They're still stuck in the BI data warehouse world of using reports to tell them what happened. That's like trying to drive your car using a rear view mirror. I mean, it's good to know where you are, but it doesn't help you figuring out where you got to go next.
What's interesting, though, is you are asking the technology people to say, okay, technology is good and all that, but I need you to think like a business person. We've heard that, frankly, for more than several years. We've tried to get technology experts, the CIOs, et cetera, to think more along the lines of business solutions. How much are you see that actually being adapted and adopted? Are people actually moving in that direction, or are you still fighting the uphill battle?
Well, the next slide, I think here, Steve, really articulates kind of our approach. We call this our value engineering framework. And what it is how do you drive collaboration between the business subject matter experts and the stakeholders with your IT and data science teams? I can't expect my business subject matter experts to become data scientists, right? And I can't expect my IT organization to understand the business as well as the business does. That's a losing proposition. Right? I wouldn't ask my IT people to understand the business like the business does any more than I'd ask the business people to understand technology. No, they have their areas of focus. They have their areas of specialization. And so what you have to do is you have to have a vehicle, a process, a framework that drives these organizations together. We call this our value engineering framework. And if you want to be valuable to the organization, by golly, you better start by focusing on a problem that's valuable to the business. We call that a business initiative. It might be to reduce unplanned operational downtime, or improve customer retention, or improve, 5- and 6-year graduation rates at universities, or, reducing inventory costs. There's a large number of these, but every organization has their key business initiatives, things that they are trying to accomplish over the next 12 to 18 months. Let's start there. Let's start with the business initiative. And the reason why I like business initiative for 2 reasons. Number one, there's usually money associated with it, right? Preferably, an M with a lot of numbers before that, right? Multi-million dollar, $10, $20, $50 million opportunities to reduce inventory costs or improve customer retention, right? The other thing about that is not only is there money attached to it, but when there's money attached to it, you tend to get the attention of the business stakeholders. And that's what's second on this thing is you need to identify and bring into this process those business stakeholders who either impact or are impacted by that initiative. You need to bring them in on day zero, not halfway through the project when you've already screwed things up and are pointed the wrong direction. They got to be not just on the boat, they got to be at the front of the boat pointing what direction to go. And then the entire secret sauce to our approach, and by the way, there's other approaches I'm sure out there. This is the one that we use. And if I had a red marker here, I'd draw a red marker around that word decisions. Because what we focus in on is going through a process, an ideation process, think lots of design thinking, facilitation kind of processes, where we identify, validate, value, and prioritize the decisions the stakeholders are trying to make in support of that business initiative. And the beauty of decisions, not questions, decisions, is that every business person I have ever talked to can immediately tell you what the most important decisions they're trying to make, because they've been trying to make them and have been making them for years, decades, generations. Who are my most important customers? When should I order a new part? When should I do maintenance on this part, right? They've been making these decisions. All we're doing is the decisions haven't changed. What's happened by virtue of the data we have and the more advanced analytics is that the answers have changed. The answers have gotten much more granular, much more predictive, much more confident. And so by focusing on decisions, we find that we can bring the subject matter experts, the business stakeholders, and leverage what they know about the business and marry them with a data scientist. And to get the business people to understand that process, we do take them through a thinking like a data scientist process. We're not going to turn them into data scientists. We're not even going to turn them into citizen data scientists, a term I hate. We're going to turn them into citizens of data science so they can respect what data science does so they can understand how best to work with it. By the way,
Bill, let me interrupt you for 1 second here. Ken,
sure. I'm on my rant. I'm going, baby.
I'm telling you something. Wow. We keep hearing about time to insights. What I'm hearing from you is, well, insights are good, but they all play toward the decision, that the reduced time to decision is what's really important here. Am I reading that correctly?
Yeah, there's two things about decisions I want to do. I want to accelerate time to decision. I also want to de-risk, right? I want to de-risk decisions. And if I can have the business stakeholders focus on decisions and I can go through a data science process with them, then I can go through a process to accelerate time to decision. I can de-risk those decisions to some level. And by the way, once I know the decisions that I'm going to go after, the analytics, the data I'm going to need, and the architecture and technology all fall out as a result, not vice versa. We don't start at the bottom and hope we can get to decisions. Right? Hope is a strategy if you're in the cosmetics industry. What we do is we start where the money is and we drive down. And that tells us what analytics we're going to need and what analytics we're not going to need, what data we're going to have to explore, what data we're not going to explore, which really takes us to what you just flipped to here, Steve, which is what we're trying to do is get the business stakeholders to take the questions on the left, the questions they're asking today, like what were revenues and profits last year and how much fertilizer did I use and how much downtime did I have. We're trying to take them through a process to change their frame. So instead of asking questions about what happened, we want them to help us understand what predictions they want to make about what is likely to happen. So for example, we convert what were revenues and profits last year becomes what will revenues and profits likely be next year, ... and what data might I need to make that prediction. That ... is really important because we find the business users have a really good perspective on what data they think we should be using. So you can see in each one of these questions, how much fertilizer will I likely need next planting season, ... and what data might I need to do that. And if I can then predict it, then I can prescribe actions that allow me to optimize those predictions. Make sense?
Makes sense.
Simple. That's the thing about this, by the way. That's the thing about this entire process. It's simple. We overcomplicate it. Right. Well, of course, we show a slide here that looks like it's incredibly complicated, and it is. And this is a slide. But the starting point the starting point for this data science collaboration process, the framework we're going to bring our users into is in step one, they're going to help us go through a very thorough process of making sure we understand in detail the problem we're trying to solve, right? What is that problem worth? What's the value from a business, organizational, operational, customer, environmental, society perspective? What are the KPIs and metrics against which I'm going to measure progress and success? Who are the stakeholders who are involved? What are the decisions they're trying to make? What predictions are they trying to make? What data might they need? And, oh, by the way, what are the costs of false positives and false negatives? Because if you don't know the costs of the false positives and false negatives, if you don't know the cost of being wrong as you build your model, then how does a data scientist know when is good enough actually good enough? And so your data science team is, after they've defined step one, they're going to go through step 2 through 6 many, many times. And you cannot measure success by how many times you go through these steps. You can't measure success by how many models they've built. You can't not measure success by how many lines of code they've written. You measure success by, are you able to have a predictive model that's greater than the cost of the false positives and the false negatives. False positives and false negatives aren't something that the data science team can determine. That must be determined by the stakeholders.
But this isn't going to happen overnight, obviously, and as we referenced down at the bottom of this slide, embracing the art of failure. Should companies expect to fail once or twice or more before they finally get it right?
Steve, when you learned how to ride a bike, did you just hop on and take off?
Oh, of course I did.
Yeah, well, yeah. I didn't, right? And when I play golf today, is every one of my strokes perfect? No, I fail a lot. We fail a lot. The thing is, in sports, for example, like in music, like being a magician, you try different things to see what works. And you learn by trying and failing, right? If you don't fail enough, you're not trying hard enough. So I think what happens here is that organizations need to understand that failure is how you learn. I don't mean, you design for failure, but you realize that failure is a natural outcome of the learning process. And so you have to help organizations understand that you're going to go through this process, trying all kinds of different data sources, all kinds of different data transformations, all kinds of different analytic models, all these different things you're going to try to find those variables and metrics that help you make the best possible prediction, given the costs of false positives and false negatives. So yeah, there's an education process here, which is why, if you flip to that next slide, we actually take our business users through a thinking like a data scientist process. They need to understand that natural exploratory curiosity, try, fail, learn, and try again process. It's more of a cultural change than it is a technology change, and helping organizations to unleash the power of across the entire organization. Let me give you a really simple example. Whenever we talk to the business subject matter experts, they, like I said before, they're already making decisions, right? They were making the decisions for a long time. In fact, many of them today have heuristics around which they're making those decisions, right? If the red light flashes 3 times and there's a shake in this particular part of the vehicle, I know that clutch is ready to go out. Really? How often does that actually happen? How is that a really good prediction? And so what we do is we bring those people in. We take a lot of their insights and what they've learned and what they've been doing and how they make decisions, and we bring them into this process, and we're going to actually try to prove that that is actually what happens. If that heuristic is actually true, then we can codify it. We can put it into a model. We can scale it, and pretty soon we can turn every technician into our best technician. We can turn every teacher and nurse and physician into our best, because we're taking the best of what they know and proving it. And if we can prove it, then we can codify it.
But if you take it back one step, you said that failure is frankly, a necessary part of success. We've heard it from other folks as well, but how many times do you fail? In other words, if I'm the CEO, if I'm the CFO, and the guy keeps coming back to me saying, yeah, this wasn't working, but we're heading in the right direction, I'm going to say, come on, guys, at what point do we have a tangible result? What do you tell those folks?
Well, if two things I was saying, right? First of all, I'll say Thomas Edison, right? He famously said, "I haven't failed. I just found 10,000 ways that won't work." Right? Thomas Edison knew that the whole world of exploration is built on trying things and failure. But I also challenge organizations. I'll challenge them by saying that if you don't have enough might moments, that is, ideas that might work, if you don't have enough might moments, you'll never have any breakthrough moments because you're not pushing the edges. And so if an organization is happy with where they are today, if they're in even keel mode, you can't change them. They're fine. Life's going good. No one's going to come along and disrupt their business model. Ha, ha, ha. Right? To be honest with you, I have no time for green bananas. I don't have time for people like that. I move on to other people who have problems and who realize that if they aren't failing enough, they're not trying enough. And if they're not trying enough, they're eventually going to get blindsided by someone who actually is.
Are you seeing an increase in the number of those kinds of companies that are saying, "Bill,
yes,
come in, we really do need help"? Why?
Yes. I think the marketplace dictates it. You have some companies who are really, really insightful, looking down the path, who have a really good strategy process and say, 5 years from now, 10 years from now, I need to be doing this. And those companies are actually really easy to work with because they already know they got to change. So competition is causing these organizations to change. Here's an interesting observation, Steve, is sometimes the organizations that are best at embracing this change aren't the large organizations. It's the medium-sized organizations where you have a CEO who's got vision and charisma, who can see down the path and say, "I'm going to change." Because in tomorrow's battlegrounds, the economies of learning are going to thwart and overpower the economies of scale. You don't need to be big to win anymore. You need to be fast. You need to be smart. You need to learn fast.
Say that again. Say that again, if you would, please, because I think that's an important point. The economies of learning
are more powerful than the economies of scale in a digital age. Right? If you can't learn faster than your competition, you're going to go out of business. I mean, it's a provocative statement that really talks about and feels back to this idea that you have to create a culture that's willing to accept intelligent failure, that each failure is a chance to learn more about your customers, your product, and your operations. Every time you get a chance to learn, you have a chance to advance. By the way, you cannot have a successful, in my humble opinion, you cannot have a successful learning organization if you do not have an organization that's willing to share with each other and stand on each other's shoulders. If you've got data silos, if you have organizational structures that prevent the sharing of learning across the organization, you're in trouble.
So on this basis now, under the sharing of information, let's go a little bit deep into the weeds here. You put together this slide, and when you and I were talking about this before, I'm looking at it and I'm going, holy cow, what the heck does all this mean? Bill, what the heck does it all mean?
Yeah. This is what everything we collect on a data science project before we ever put science to the data. This is all the stuff we do in collaboration with our business users, our stakeholders, our subject matter experts, to understand and scope the problem before we ever dive in from a data science perspective. Because the data science process can go so many different directions, you have to put some sort of guardrails around it, not railroad tracks, but guardrails. So you define, for example, what's the problem we're trying to solve, the decision, the hypothesis, right, number one. Number two, how am I going to measure progress and success? What are the metrics and KPIs that I need to be tracking and trying to optimize across? The beauty of that, by the way, the beauty by that immediately is a lot of these KPIs and metrics are not, they are not in alignment. Some of them work opposite of each other, right? So I love that. When you have conflicting metrics and conflicting variables, that's where innovation happens. When you're trying to, increase uptime while reducing inventory costs, right? That's a great conversation because I can easily increase uptime if I don't care about inventory costs, or if I want to reduce inventory costs and don't care about uptime, that's easy too. Life gets hard when you have these conflicting metrics. And by the way, take 5, 6, 7, 8 of them. and bury them against each other. That's where innovation happens. That's where all the hard stuff happens. That's where real value is created. Anyway, so you can see along this thing, this is all the stuff that we capture as part of our thinking like a data scientist process. And number 12, panel number 12, is the risk associated with the cost of false positives and false negatives, to have a really good understanding on what that means if our model's wrong, what it costs people.
Isn't it important, though, and this gets into where Io-Tahoe plays, to have a complete and total understanding of what data you really do have under your control, the data where you have it and who has access to it and where it resides across the entire organization? Because it seems to me, and maybe I'm wrong, but if you can't figure out what you have, then how are you going to search it? How are you going to best utilize it in a data science project?
It reminds me of you got a bag of coins upstairs in the attic, sitting up there. You know you got a bag of coins, but you've never opened the thing up to see what's in there. And so you finally open the thing up and you start digging through and realize, wow, there's some silver quarters here. There's some rare pennies here. There's some rare coins. Right? If you don't go through that process of digging through and understanding what you have, how do you know what's valuable and what's not valuable? So there's that process of really digging through and understanding what data you have and getting a really deep understanding of it. But many organizations falter, especially IT organizations, by thinking about only the data they control. What about the data your marketing analyst person has got on their server somewhere? A bunch of files they've downloaded, they've been screen scraping and pulling data. They've even bought data sources, right? So these organizations have data sources scattered all across the organization. And I think that's important that an organization gets their hands on what all data do I have, do that inventory, because if I don't know if I have it, then how do I figure out if it's valuable or not?
And it would seem to me that with the immense amounts of petabytes, terabytes, and on from there, that you can't do it by yourself anymore. In other words, manual data discovery simply doesn't cut it. If anything, it seems to me that it would be a negative because you assume that you're going to have something when you don't really have the full picture.
It's like taking a drink of water from a fire hydrant. You're just going to get wet, right? It's if you try to do this manually, good luck. It's not possible. You probably have people across your organization grabbing data faster than you have any idea how to figure out what they're capturing. So if you don't have an automated process for capturing, tracking, indexing, and cataloging that, you're going to be in a world of hurt.
Well, which gets us into the whole concept of design and data science. And you have all this data. Now, how are we going to put it together? And what are we going to do with it once we've done so?
Yeah, so the thing that we do, each of our data science pods, so whenever we attack a project, we attack with a pod concept, which got a data scientist, it has some data engineers, it has a junior data scientist, it has a value engineer, it's got the business subject matter experts, and we have a design thinker that sits on our organization. So, and the reason why we have a design thinker in our organization who sits on these pods is because while data science is great at uncovering and codifying the trends, patterns, and relationship buried in the data, design thinking techniques can do the same thing in uncovering those trends, patterns, and relationships buried in the heads of your subject matter experts. The heuristics, right? What data sets are you using to make those decisions? What data sets would you want to use? So we basically blend together design thinking and data science into the same process so that it isn't just the numbers. It's not just the hard data, the hard facts that come out of the data, but it's the soft facts that are in people's head that sometimes are actually, well, I'm going to say they're more valuable, but they're equally valuable in making sure you're going after the right problems, the right data sets, and trying to build the right models.
Which then, as I say, takes us one step higher. And if we go back to something that you're teaching over at USF, the economic value of data research. And this goes back to what we started talking about right at the very top, that data is the new oil. No, that's not the case. It's even more valuable than oil.
Yeah, it's more valuable than oil. It's never depletes, never wears out. Maybe you should build this thing out here, Steve. So the next one is, I talk about how, as we did our research project here, one of the things that occurred to us as we're trying to figure out the value of oil, the value of data. So this whole project started with a value of data focus on it. And we went down the typical accounting approach. We looked at all what the analysts were doing out there, read a lot of analyst books about, how does data fit into a balance sheet? And then we had this epiphany. It wasn't mine, it was one of my students, right? This is the advantage of teaching, by the way. I get to take all the best thinking from these students and their creative perspectives, and they're not afraid to try ideas and fail. And we realized that it was actually more of an economic process. In fact, data looks like it actually prospers from the economic multiplier effect, if you remember your economics, and the marginal propensity to consume. So for example, let's say I have a point of sale data, and I want to use that data in order to improve sales promotional effectiveness. And it's going to improve it by 2.5%. That 2.5% is worth something. It has value. I don't know if it's worth $50,000 or $50 million, but I'm going to solve that problem using that customer point of sale data. I'm going to curate the data, get index, catalog, normalize, enrich it, metadata management, right, governance around it, all the sort of things, because that data, that customer point of sales data is valuable and helps me to derive value from that promotional effectiveness use case. But now, once I have that data available, probably in my data lake, I would argue, marketing can use that same exact data, curated data set, to improve customer acquisition by 2%, which has some value. And the call center can use it to improve customer retention by some percent, right? And the next one is the new product development can use it to introduce new products, right? Each of these use cases has value. Each of these use cases has some sense of financial economic value. And the power here is I'm using the same customer point of sales data, the curated customer point of sales data, over and over and over again when the marginal cost equal to 0, which means my marginal propensity to consume, if you remember your economics, as MPC starts to approach 1, the economic value of that asset starts to approach sideways 8, right? Infinity. How do you think about the power of this? That same data set. Now, if I understand how valuable that customer point of sales data set is, and not all data sets are of equal value. Here's mistake number one that organizations make, that CIOs make, that chief data officers make, is that all my data is valuable. Bullshit. No, it's not. No, some data is a lot more valuable than other data. And so you need to go through a process to really understand what's valuable. So now I know how valuable that data is. No, where am I going to invest money to try to improve the completeness, the accuracy, the latency, the granularity of these data sets? Well, by golly, I'm going to focus it on that point of sales data set, because I can use it over and over and over again at a marginal cost equal to 0.
And that goes back to something you and I were talking about when we were discussing this presentation beforehand. For the geeks out there, I referred to it as object-oriented data science, object-oriented data discovery.
I love it. That's a great term, because what I've done is I've turned this example, the customer point of sales data, into an object I can reuse over and over and over again. And in fact, why I like this model, Steve, is because any enhancements I make to that data, all of these use cases inherit. They inherit that modifications, that improvements, which jump down to the next slide. This is my you think I'm passionate about this, wait, take us next slide. So this is my effort to try to win a Nobel Prize in economics. And I call it the Schmarzo Economic Digital Asset Valuation Theorem, because it's got to have my name in it. When you start treating your data and analytics as these objects, self-contained objects, there are 3 effects that happen. Number one, across a number of use cases, the marginal costs start to flatten by reusing the curated data and the analytic modules. By the way, when I build analytics, I'm not building one-off analytics. I'm building my analytics as products. I'm in a software company here, Steve, and when we build analytics, they get built as a product. Version control, check-in, check-out, regression testing, they're not one-off analytics. We saw this problem called orphaned analytics when we were doing this research at USF about how some of these organizations were really, really good at analytics. They were much better than what I would ever be, but they were so good at them that they never packaged them in a way that allowed them to share them, reuse them. So this gets to that culture. If I can share and reuse my data and my analytics across my use cases, eventually, number one, my marginal costs flatten. Effect number 2, though, is, we talked about this earlier, if I can reuse my data and I can reuse these analytic modules, I can accelerate time to value and de-risk projects. And so the first use case, maybe it takes 9 months to get it out and get it right, but my second one, because I'm starting to reuse, takes 7 months, and all of a sudden it takes 6 and then 5, and now I'm doing 2 or 3 use cases simultaneously because I'm reusing these analytic objects, these object-oriented kind of data and analytics, right? But here's number 3. This is the inheritance effect. You got me thinking about this, Steve, right? Any improvements that I make to the data or the analytics ripples back to all the use cases that use that. Let me give you an example. Let's say I build an analytic module around anomaly detection. We've got one of those, right? And we use anomaly detection in things like supplier quality and supplier reliability, inventory management, performance optimization. We're using that anomaly detection module across a large number of use cases. Say one of my big giant brained data scientists figures out that if I use a deep reinforcement learning with convolutional neural networks, I can actually improve the effectiveness, the predictive effectiveness of that module by 1%. I can make it 1% more effective. All of a sudden, every use case that used that analytic module inherits that 1% improvement. And you see this astronomical jump effect where things take off. Because by the way, if you were to make, as a human, if we were to make a 1% improvement every day for a year, in whether it's your health or whatever it might be, a 1% improvement over 365 days compounds into a 37x improvement by the end of the year. So you can see how if you can reuse the data and analytics as these objects, as you said, Steve, the effect number 3 is all about the inheritance and how the economic value just explodes.
So let's start wrapping it up at this point, and to recap one of the.
Well, I'm just having fun. I'm just having fun. Are you kidding me? I'm just having fun.
I know. I know. I mean, look, data is not the new oil. Okay. I mean, you've got. We've been talking about this throughout this hour, and you said that put another way, data's the new sun.
Yep.
And the more that the companies are going to really recognize that and move on it. If I were going to say to you, Bill, if you had to come up with your top 3 recommendations for companies that are saying, I really should do something like this, what would those top 3, top 5 be at this point?
Number 1, I would say, wow, that's a good question, Steve. You caught me off guard in this one. I love it. Love being caught off guard. I say, so number 1, I would say, treat this as an economics conversation, not a technology conversation. That'd be recommendation number 1, right? Recommendation number 2, it's a business initiative, not an IT initiative. What I mean by that is if you think that you're going to have your data science team and IT team do this magically and somehow magically deliver value to the organization, you've already lost, right? So number 1 is it's an economic conversation, not a technology. And number 2, it's a business initiative, not an IT initiative. Number 3, embrace the power of failure and learning. I think that is key, right? Is you got to be willing, if you want to learn, you got to be willing to fail. That is, people don't, I mean, we know that as kids growing up, that's how you learn. That's how you learn to play golf, how you learn to ski, how you learn to ride a bike, right? We learn by failing. But we seem, once we get into high school and college, we seem to view failure as something to be avoided, not as a natural way of learning. Number 4. I think
you got it. That's great. Go.
No, I do. I'm going to have 5 for you. Are you kidding me? I could go on.
Okay.
Number 5 is to really treat data as truly an economic asset, not an accounting asset. That is, that the value comes in the reuse of these assets across a number of different use cases. And number 5, buy my books. If you want to learn more, buy my books. little plug there.
Just a very so subtle plug there. I can tell you, Bill Schmarzo, the CTO of IoT and Analytics with Hitachi Vantara, and the Dean of Big Data. You now see why. Oh, by the way, Bill, where can they buy your books if so interested?
Yeah, so the first 2 books you can actually buy on Amazon, Big Data and Big Data NBA. By the way, Big Data NBA is the textbook I use for my classes. The 3rd book, The Art of Thinking Like a Data Scientist, I self-published. I wanted to keep the price down. So I really targeted for my classes. So that it's only available as an ebook. You can download it. You can put it in a Kindle and still read it. It reads long ways, but it's truly is a workbook that we use in our class for our Thinking Like a Data Scientist exercise.
And where can they get that from? Where can they download it?
You got to go to deanofbigdata.com and you'll find it there.
There you go. Bill, it is always a pleasure. I can't say thank you enough, but I will try. Thank you, Bill. Thank you for everybody who attended from around the world, who attended the latest in the Io-Tahoe series of online webinars. This will be available on demand at iotahoe.com/webinars if you want to share it with others or just want to listen to it again. And hope that you do, and hope you check out the other ones as well. For Bill, I'm Steve Friedberg. Thanks very much for joining us. Stay well.